My name is Theo, and I'm a second year at UC Berkeley studying chemical engineering. I'm part of the BMT problem writing team, and today I'll be covering relay number 17 from BMMT 2024. So in this problem, Zane is biking on the coordinate plane, and his pattern is defined such that it starts at 0, 0, and he goes forward and turns left whenever he can. So for example, we'll go from 0, 0 to 0, 1, and since we can turn left to an unoccupied square, we'll go left. And again, we can turn left to an unoccupied square and go left. Now, once Zane is at -1, 0, he can no longer turn left, because this would cause him to run into his path at 0, 0. So instead, he'll keep going, and we can sort of see this nice spiral pattern develop in Zane's path. Like that. And this will continue on and on, presumably to infinity, where Zane will probably get pretty tired, but he can do it. So in this problem, we want to find the 4,144th point in Zane's path at which the sum of his x and y coordinate has absolute value 2024. So we can probably guess that this will take a really long time, because at least for the first few points in the path, 0, 0, 0, 1, -1, 1, the sum of the absolute value of the coordinates is pretty small. We start at 0, 1, 0, and we can guess that it won't reach 2024 for a pretty long time. So instead of trying to tackle this right away, it might be beneficial to sort of explore what happens if we replace 2024 with a smaller number. In this case, I like 2. So let's try and see what happens when x plus y is equal to 2. So we can sort of just trace along the path and note the points at which the sum of the x and y coordinates has absolute value 2. So we'll trace along, it's 0, and then 1, and then 0, and then 1, and then 2. So here's the first instance, and then 1, and then 0, and then 1, and then 2, and then 3, and then 2, and then not 2, and not 2, and 2. And as we go around, we'll start to see that this really nice pattern emerges, where all the points that satisfy this criterion lie on this nice line intersecting the corner here. And so let's sort of like count and maybe see where the 4,144th intersection between this condition and Zane's path lies. So we can count that the first intersection is here, and then we go around, the second intersection is here, the third intersection is here, the fourth intersection is here, 5, and 6, and 7, and 8, and 9, and so on. And what we observe, which is super nice, is that the nth intersection is pretty close to the n plus 4th intersection. For example, the second intersection is pretty close to the 6th intersection, and we can guess that the 8th intersection, or sorry, not 8th, the 10th intersection will happen here. And similarly, we see the 3rd intersection and the 7th intersection, and the 11th intersection, and it will continue up here where these are of the form 4n plus 3. So checking out 4,144, we see that this is a multiple of 4, so we'll probably line a line with all of the multiples of 4, which will be in this direction, where we have 4, 8, presumably 12, 16, and so on, hopefully all the way up to 4,144. So we notice that the multiples of 4 lie on this line in this direction, just as the intersections that are equivalent to like 3 mod 4, so intersections of the form 4n plus 3, and intersections of the form 4n plus 2, and intersections of the form 4n plus 1, all lie in these directions. And so we can sort of note a pattern among the intersections that are multiples of 4, where the 4th intersection is at -1, 0, and the 8th intersection is at -2, 1, and the 12th intersection is at -3, 2, and so on. So to get from the 4nth intersection to the 4n plus 4th intersection, we just sort of move left by 1 and up by 1. So now let's check how long it takes to get to the 4,144th intersection. Or in other words, how many steps, 1 to the left and 1 up, do we have to take from the 4th intersection to get to the 4,144th intersection? Well, that's just 4,144 minus 4 over 4. This is 4, 1, 40 over 4 which is 1, 0, 3, 5. That looks right. And so now, if we step 1 to the left and 1 up 1,035 times, then this is equivalent to stepping 1,035 to the left and 1,035 up. So from this point, we'll step 1,035 to the left, which will put us at negative 1036, and 1,035 up, which will put us at 1035. So this is, miraculously, somehow we found the 4,144th intersection, unfortunately, with this set of lines. But that's not the set of lines we were originally interested in. We want to know when do we have the 4,144th intersection with x plus y has absolute value 2024. So instead of doing this, we can just imagine what happens if we extend the lines outward. So for example, the lines such that x plus y is equal to 4 look like this, a little bit farther out. It's approximate. And if we just keep stretching, eventually we'll get the lines that correspond to x plus y is equal to 2024. And maybe by playing around, we can see that if this number on the right is even, we'll always sort of hit this intersection at the corner, and then every lap after that, we'll increase the amount of intersections with the lines by 4 along the spiral path. So that means that we can sort of intuit that the first intersection will be at negative 10, 10, 12, negative 10, 12. And based on the same argument here, the fourth intersection will be at negative 10, 13, negative 10, 11. And just as before, we need to take 1035 steps up and to the left. So we need to add negative 1035, positive 1035 to this to get to the 4,144th intersection. So adding these gives us negative 2048 and positive 48. And this is wrong. Because the 35 plus negative 11 is not 48, but 24. Yeah, sorry about that. So then this is the point of intersection, and I think the problem statement initially requests the second coordinate, so the answer is 24.